Okay, so we're going to focus on hyperbolas centered at the origin right now. And so there are two equations. One is x squared over a squared minus y squared over b squared equals 1. So it's very similar to the equation of an ellipse. You can see that the big difference is that subtraction sign. That's the difference. So when you're looking at equations and you're trying to decide is it an ellipse, is it a hyperbola, that's what you have to look at. Okay, now this kind, where x squared is first, those are going to open to the side. That's going to be a side-to-side hyperbola. Okay? The other equation, you probably guess, is y squared over a squared minus x squared over b squared equals 1. Those kind are going to open up and down. Okay, so you know subtraction is not commutative. It makes a difference which one's coming first in these equations because of the subtraction. Okay, so now we'll go through the details, hopefully. All right, so first we're going to do a sideways one. So x squared over a squared minus y squared over b squared equals 1. Okay, so you have a transverse axis. Let's put it in orange. Transverse axis. And so that's going to be equal to 2a. All right, so this distance here between the vertices is going to be 2a. Now, you're also going to have the conjugate axis, should be halfway in the middle, and then the co-vertices are going to be here. Okay, so the conjugate axis is 2b. Okay, for some reason. Okay, the center is the origin right here. I'll just put that in because we said we were centered at the origin. Let's see, what else did I want to say on this? Oh, the vertices. So the vertices for this kind are plus or minus a comma 0. The co-vertices are 0 plus or minus b. Okay, so you could probably kind of gather that, kind of like what we did with the ellipse and everything. But the distance then between the center and the vertex, that is a. And the same thing over here, that is a. And then the distance between the center and the co-vertex is b. And the same thing up here, b. Okay. So when you're graphing them, if you know what a and b are, similar to how we did the ellipse, we can graph those. Okay, now we're going to draw that central rectangle. Like that. The asymptotes go from the corners through the center. I've seen students draw them and they don't always go through the center, but you've got to go through the center. Now you can see that kind of divides the graph paper into 4 sections, right? You have a kind of a V shape up at the top and one at the bottom, and then you have the 2 to the side. Because it was x squared first, x squared over a squared minus y squared over b squared, this is going to open side to side. Okay, so I can draw the hyperbola, and I'm not great at drawing these. I usually just go from the vertex toward the asymptote, and I do it on each side, and then the same thing here. And that is graphed. Now, where are the foci? Well, there's going to be one in here and one in here. And I think of the hyperbola like wrapping around, the points are wrapping around the foci. The distance between the foci is 2c. And c squared, now here's another change. C squared equals a squared plus b squared. Okay, so notice that difference there on the c squared. So you have to remember that. Oh, and the coordinates for the foci, for a side-to-side one, is plus or minus c, comma, 0. Okay, the other thing we have are equations for the asymptotes. So those are linear. And so the equations for the asymptotes, for this kind, you get y equals plus or minus b over ax. So those are the equations. There's two equations, one with a plus and one with a minus, and it has to do with the slope of those asymptotes. Okay, so that's a side-to-side one. And now we can do an up and down one. We're still going to have a transverse axis, which is going to be up and down, and a conjugate axis, which is going to be side to side. Now notice it doesn't matter which one's bigger, okay? So this time, this is the transverse axis. Oops, trans, and this is the conjugate. Okay, now I didn't write the equation and I need to do that. This is for y squared over a squared minus x squared over b squared equals 1. Okay, this is still the center at the origin. And then this distance here is a, and this distance here is a. So the transverse axis is still 2a. And then this distance is b, and this distance is b. And so the conjugate axis has a length of 2b. Now, where are the vertices? The vertices are up here and here. They're on the transverse axis, so you have to remember that. And the vertices are going to be 0, comma, plus or minus a. The co-vertices are going to be over here. So co-vertices are going to be at plus or minus b, comma, 0. Okay. So you draw the central rectangle going through the vertices and the co-vertices. And you draw the asymptotes, which my equation's in the way. I'm drawing the asymptotes. This is a little easier to do on graph paper. Okay, but now where are the foci? Well, the foci are up in here and down here. They're on the transverse axis. I just didn't extend my transverse axis. I usually do. Okay, so the foci are going to be at 0 plus or minus c. And it still holds that c squared equals a squared plus b squared. Okay, so to draw these hyperbolas, we're going to go toward the asymptotes. So you can see this is a little bit wider hyperbola. Sometimes they are. And it's going like that. All right. The only other thing we need then are the equations for the asymptotes. And so the asymptotes are going to be at y equals plus or minus a over bx. Okay. So those are all the details for the hyperbolas and how you graph them. We're going to give you an example here in the next video for both the kind that open side to side and up and down.